Okay, Algebra 2 students, here is the first video for section 5.4. We're going to solve radical equations. How can you solve equations that include radicals or rational exponents? The vocab, extraneous solution, and in the end you're going to be able to solve radical and equations and inequalities. Let's go ahead to example 1. Solve an equation with one radical. Here we have a radical equation. Square root of x squared plus 5 minus 1 equals 3. The first thing is to get the square root by itself, so we're going to add 1 to both sides. And then, this is what I hate, they show the whole solution and you don't really have time to process it. I add 1 to both sides to get square root of x plus 5 equals 4. Then to undo the square root, we're going to square both sides. Whatever you do to the left side, you got to do to the right side. So when you square this, you get x plus 5. When you square 4, you get 16. And now, subtract 5 from both sides, you get x equal 11. Final answer, x equal 11. However, you need to check it. This is very important at the end of these to check the answer, because when you square both sides, you could create an extraneous root, one that doesn't work. So when we plug in 11, 11 plus 5 is 16. Square root of 16 is 4. 4 minus 1 is 3. So it does work. That's what they have here. It does work. And for some reason, they graph both. We haven't talked about a graph of a square root equation, but it often has this kind of a form to it. I digress. Moving on. Solving this radical equation. We're going to isolate the square root, but it's not a square root. It's a cube root. So we're going to subtract 2 from both sides. After they subtract 2 from both sides, they get the cube root of x equals 2. And because it's the cube root, we're going to cube both sides. So when you cube the cube root, you get x. And when you cube 2, you get 8. So now we know x equals 8. But then we got to plug 8 back into the original equation to see if it's true or not. And when you take the cube root of 8, you get 2. And 2 plus 2 is 4, so it does work. So that is the answer. Let's see what they want us to try. There's 2 equations for you to try. Click pause and come on back when you're ready. All right, first step is to isolate the square root. So I'm going to subtract 3 from both sides. And I'm going to get x minus 2, or the square root of x minus 2, equals 2. And then I'm going to square both sides. And when I square both sides, it's going to get rid of the square root. So I'm going to have just x minus 2. But I got to square this side too, so it's x minus 2 equals 4. And then I'm going to add 2 to both sides, so x equals 6 is my answer. Now I need to substitute that back in. 6 minus 2 is 4. The square root of 4 is 2, and 2 plus 3 is 5. So yeah, that works. So this is the answer for the first question. You can click pause if you want to try the second one if you haven't already. Here we go. The square root's already isolated, or the cube root's already isolated. So I can just cube both sides. When I cube the left-hand side, I get x minus 1. When you cube the right-hand side, 2 cubed is 8. And then it's just one more step. Add 1 both sides. So I'm getting x is 9 is the answer I'm getting. Now let's see if that works. 9 minus 1 is 8. And the cube root of 8 is 2. So yeah, that works. Maybe extraneous solutions don't show up until the next example. But for now, you can do these problems from 270 and 271. That's it for this video. Have a great day.